The topic to be covered in today's class of operating system is related to file management. Having seen the various operations you can perform on a file, now we'll go to the actual system calls which can be used to perform these operations when we go for our programming concept. So when I want to create a file, the function we'll be using here is create, and this accepts two arguments. One is your file name and this is nothing but your mode. So file name is the name of the file which you want to create, and when you go for your mode you have different options of your mode. These are IR, IR, USR. This indicates that these are different modes and the symbolic constants are to be used as it is. So here R indicates that you want to perform read operation, and for what, to which particular user. You have three types of users. So here it is for owner. WUSR is for write operation for the user, execute operation for the user. Here indicates the owner. And IRGPR GRP is for your group. R indicates it is read, W indicates write, and XGRP indicates that you want to execute operation on a group. And similarly, if you want to provide operation for your others, it is IROTH, read for others, write for others, and execute for others. And if you are successfully creating a file, it will be returning you the descriptor as the output, otherwise it returns a value -1. Assume after creating a file, I mean you haven't created a file directly, you want to go for create opening a file here. So when you want to open a file, you can even create a file at the time of opening. You mention the name of the file. So here file is the name of the file. And when you go for mode here, the mode of creation and here the modes which are used for opening a file are quite different. Here you are indicating two particular modes here, and two of the modes can be separated with an odd symbol. So this is your XOR symbol normally we use. It indicates that if the file by name whatever you are specifying is not existing, you create a file and try to open a file. If the file name whatever you have specified here is already existing, you need not create a file, you need to just open that file. And in which mode you are opening the file, it is nothing but RDWR, which indicates it is for read and write. So when you want to open a file, you can either open it for only read operation, write operation, read, write, or you create a file if it is not existing. You can prevent a creation of a file if it is already existing. You can perform append operations. So these are the general modes we'll be using for opening a file. And once you open a file or you create a file, here you want to perform what are the basic operations I'll perform on a file. Either you read the content from the file or either you go for writing the content onto the file. So I want to just read the content of the file. So when you are opening a file, what is the output of the file? It is returning your file descriptor, means a pointer which is pointing to your actual file, and this particular file is present in your main memory. So whenever you want to access this particular file present in the main memory, you need not write the file name every time. You can just use this file descriptor. So when you are reading a file, you just mention your file descriptor, and whatever you are reading that will be stored in your buffer, and this buffer will be specified with the maximum length. So you can just see the example here. N is equal to read of 0 comma buffer comma 50 means this is the size of your buffer, and this output, the return type of your read is nothing but it returns you number of bytes that are being read into the buffer. Similarly, when you want to perform a write operations, specify the file descriptor as one of the argument. You write the data. So from where you will be writing, you write it into the file. Here you are reading from the file and storing it in your buffer, and this is the length of the buffer. When you are going for writing, where you will write whatever you have in your buffer, the specified length of the buffer will be written onto your file. So if you just see this example here, n is equal to write on this file which is being pointed by FD. You have a file here. What you are writing a word hello, and this is the size of this particular text. And you finished performing read and write operation. You need to since you have opened a file, it is the responsibility of the user to close the file, and the syntax for closing the file is int close of int fd. You will be passing an argument which is related to your file descriptor. Now clubbing all these system calls which we have seen, we'll just see an example here. I'll not explain you each and every line, just concentrate on the lines. Here you are reading it. So here in read, you have to specify the file descriptor. But in read, if I'm specifying of instead of a file descriptor, if I write 0, it means that you're reading from an input device, which is nothing but a keyboard. So whatever you're reading from the keyboard, you're storing onto your buffer, right? And after that, you're opening a file by name file. And if it is not existing, you go for create a file. And these are your operations. So these 0777 is nothing but an operation. So this is for your owner, this is for your group, this is for your others, and this indicates an octal number, which we have already seen in your Linux operating system file systems. And you are opening a file in read as well as write mode. So whatever is present in your buffer, so that is being dumped into your file descriptor, and the length of the characters that are to be read from the buffer is specified by n. So you are reading from the keyboard, and whatever you are read from the keyboard is being stored in your buffer, and from the buffer you are taking n number of characters and storing it in your file. Now the data is available onto your file. But how do you display this data? So you have to again write it onto the monitor. So what is the operation I need to use here? Write operation. And if you want to specify that you want to write into a monitor, no, write onto the monitor without a file, you specify it as 1, from where you have to take the data again from the buffer and the number of characters that are to be written onto the monitor. You'll just close the file. Now, the other operation that has been used here in the file management system called is lseek. Normally, when you have your file content like this, the file pointer will be moved one position ahead, one after the other. Now, for example, after this fifth character in this example, I want to include a character hello here. So you cannot just type the character hello and say that it will be added here. So you have to move the file pointer from first position to this fifth position. Normally, if I click one by one, it will be going sequentially one after the other. But from here, I want my file pointer to directly move to this particular location. For that, we go for using L6. So these normally we call it as random access files, file functions, which will make your file pointer to move from one position to the specified position. So here we'll go for using three constants seek set. So you specify that from the current, the seek set is from the beginning, seek current is from the current position wherever may be the file pointer, and seek end is nothing but from the end of the file. So you are specifying three locations in a file, either from the beginning you want to move a file pointer, either from the current position of the file pointer, or either from the end. So here if I write fd is the file descriptor which points to the file, and these are the number of positions you are making a file pointer to move. From where seek set, from the beginning you want to move 5 positions ahead into your file. If you want to move 5 positions forward from the current position, then you can write seek current. And similarly, you can make your file position to move forward as well as backward. So in place of your positive integer value, if I just provide a negative value, it means that from the current position, you can either move backward also. So from the end, you can move backwards, and from the current position, you can move backwards. But when you go for set, since it is at the beginning of the file, you cannot move backward because it is a starting position in the file. Now we have another system calls here which are related to link here. So as we have already seen, when you have gone for linked allocation, where you have two files which are been pointing, when you want a file to be shared between two users, either I can go for creating a soft link or a hard link. So when you go for a hard link, you have the file which is actually present here, and you are creating another pointer which is pointing to the same data. Whereas in soft link, you will be just providing the data. You just access the data from the file. You will not go for accessing the data from the actual position. So the data is already present in the file. You try to get the data from this file rather than going to the original copy of the data. So when you go for creating links, you can either create a hard link or you can go for creating a soft link. So when I want to create an hard link here, so we go for using a function link, and you specify the old path as well as the new path. So old path is nothing but the file data which is already existing, path name of the existing file, and the new link whatever you want to create. So then a link will be established to both of them. Now, when you want to go for creating, after you have established a link, you want to go for removing that particular link. So you want to delete a link. So you can just write it as unlink. So you unlink means the link which was being established will be deleted. Now if you have two links pointing to a file, right, and two of the links are being deleted, then the original file which was being linked up will also be deleted. But if you have a file and if you are deleting only one particular link and a link is still already existing, this particular file will not be deleted. And when you see this example here, we go for using three system calls. One we call it as link, which is used for creating a hard link. The other we call it as symlink, which is used for creating a soft link. Soft link will only point to, you only have the address of it. You are not pointing to the actual data. You only point to the file which already contains the data here rather than to the actual data. And you can go for deleting a link by using unlink. So if you can just see here, we are specifying the source file, hard link, and your system link, or you call it as symlink. So here symlink here is nothing but your symbolic link. It is as of your shortcut. So whenever we are installing some particular apps here, we get a shortcut onto the desktop. It means that it is not the original file. When I delete the original file, this shortcut will not be working. So it just acts as a shortcut, but it is not your actual data. So link, you are specifying your source file and your hard link. And if you are able to successfully create, you get your hard link. And similarly, if you want to create your symbolic link or the soft link, symbolic link is also known as your soft link. You got the name of that particular file which is been created. And once your symbolic link or hard link, soft link is created, you can delete it by using unlink. Now, we want to know the different types of status information. So when I go for the status of a file, so what are the different types of information, status information you want it from the file? It is nothing but related to the file size. It is the size of your file, who is the owner of the file, what is the permission given to that particular file. So the attributes or the metadata related to a particular file will be stored in a status information. So if you want to know the status information of a particular file specified by its path, then we go for using a function known as stat. If you want to just know the status information of a file which is being opened by the user and you are performing some operation on that, we go for using fstat. And if you want to know the status information of a particular file, but here you are talking about a symbolic link. So if you want to know, rather than you want to retrieve the information of a symbolic link itself rather than the file which is pointing to, you want the status information of a link but not a file. So in that case we go for using lstat. So it is nothing but link status. So in any of these cases you are just getting the status information. So in stat, you specify the path of the file for which you want the status and pass your status structure status pointer as an argument here. Similarly, if you want to know the status information of a file which is being opened, then you can go for using fstat and the argument would be same. The file descriptor of the file which is being opened and the buffer. It is a pointer to a structure buffer, and you have your lstat which will tell you the information about the symbolic link rather than your actual file which is it is pointing to. Now coming to the next system calls file management here. We have change mode. Change mode in the sense while creating your directory or while you are creating your file, you system will automatically provide you some permissions. Permissions in the sense whether you can perform read, write or execute permissions, or the user can specify the permissions while creating a file. But you want to change that, you want to change the mode, you want to change the permissions given to a file. So in that case you can just write change mode, specify the name of the file for which you want to change the permissions, and you specify or you set your own permissions. So the first two leading zeros indicate that it is an octal number, and as you all know 444 here, 4 is a decimal value which is related to read operation. So if I am writing 444 thrice, it means that you are only providing read operation for owner, group as well as the guest, or you call it as others. If you want to change the owner for each of the file, whether it is a file or a directory, that particular directory or a file will have a owner. So you want to change the owner of that particular file. You can go for using own change owner. You can specify the path of the file for which you want to change the owner. You can specify the ID of the owner for which you want to give a new access, and you can even give it for your group. In place of the ID, if you are writing -1, it means that the owner is not changed. The original person who has created the file would be as it is using the same file. If you want to see a sample program here, it is related to you are creating an ID for the new owner, and this is an ID for the group. So if you want to change the owner permissions of this, you specify the path for which you want to change the permission, the new owner ID and your new group ID. If you are able to successfully complete this operation, the owner permission will be changed. Otherwise, it gives you an error stating that it has not been changed.